Hi everyone, this is Mrs. Davis, and I am here to talk about different ways that we study a population size. So if we think about all the different organisms that we have around the world, how do we get a feel for just how many there are, and how do we know when we're in danger of losing them or when we're in trouble with having way too many? So we're going to look at 4 different methods today. To start us off, let's take a look at a question. How many beans are in this jar? So if you only have 2 minutes and you're unable to open the jar, what method would you use to try and make an estimate of how many jelly beans are in the jar? Take a moment to think about that and write it down. And this might be a good time to pause. Me, if you need a little bit more time to think about your answer. So what I would say, looking at this problem, and I'm sure you all come up with your own creative solutions to this, is that maybe I would count a ring of jelly beans, um, or a level of jelly beans rather, by looking at the bottom of the glass, so see how many jelly beans there are in a level. And then I would multiply that based off of what the height of jelly beans are in the jar. And hopefully I would get somewhat close, because I wouldn't be able to physically touch the jelly beans, and I wouldn't be able to open the jar to count them individually. So there just wouldn't be enough time either. And this is a struggle for a lot of ecologists that want to study a population. They can't physically see every single species, and they don't have enough time to count every single one either. So what we do with showing this example is it kind of gives you a little bit of an insight into the challenge of determining the number of organisms in a population. This is a method that could be used for studying a population, the one that I described, and it would be known as sampling. Okay, so why do we study organism populations? Why is it important? And one of the reasons why it's so important is because we need to know when our populations are too high or too low. So some bad things that can happen when a population is too high, say if our deer population were to become too high, then we might see more car accidents occur. Or if we have an increase in mosquitoes that are carriers of a certain disease or virus, then if their population starts to increase, then we know that we're in trouble for contracting that virus. So it's good to keep an eye on these populations and really understand how delicate our ecosystems are, that we need to understand when they are getting out of balance. So there are 4 methods for determining population size. There are direct observation methods, indirect observation, sampling, and mark and recapture. So we'll start with direct. It's the most obvious. It just means you're counting every single one. So this method works best when you have the organism cornered, so to speak. So I could easily count the number of students in a class, so long as, it wasn't in the middle of changing classes. Everyone would be seated in the classroom. I could see everyone, and there wouldn't be too many of you that I wouldn't be able to count. I'm not going to count everyone in a stadium using direct observation, but if it's a small enough space where the organism is not fleeing or on the move, then it's easy enough to count directly. Indirect observation, so instead of counting the actual organism, we're counting signs that the organism was there. So maybe we're looking for tracks in the snow, or if we want to continue with the classroom example, maybe, you all went to lunch for the split period that's going to now be between lunch with that block schedule. You all went and you left your book bags in the classroom, which I don't think is something we're going to be doing, but if you were to do that and I counted the book bags, I would be counting a sign that you were there, but I wouldn't be counting you. So that would be an indirect observation. And sometimes this would be less accurate than the direct observation. Sampling. So sampling works kind of like how I explained the jelly bean example. You look at a large area, you count the number of the organism in a smaller area, and then you use that as a generalization for the entire area. So you're going to multiply that over the whole field. Say if I was doing this dandelion example, maybe I would measure the number of dandelions in a square foot, and then I would multiply that over however many square feet my field is. Mark and recapture is a method where we are actually going to tag the animal with some type of device or mark, and we'll do some calculations based off of how many of those organisms we recapture that still have tags and how many do not have tags. So assuming that we can still have the same ability to recapture the organisms that we were able to capture the first time around, if I see that there are a lot of organisms that don't have tags, then I can assume that there are a lot of new birds or organisms that enter the population. So I would say population is increasing. Okay, so each method has pros and cons, and that's why we have different methods. If there was a method that didn't have any cons, then I could just use that method for all scenarios, but we need to pick which method works best for what scenario. Direct observation, it's excellent because it's very accurate, right? We're not making an estimate, and it's simple and obvious, and just count them. It's not always practical, especially in large areas, and it doesn't work well for moving organisms. So if I have fast moving organisms, I'm not going to have enough time to count every single one. And certainly in a large area, I'm not going to sit in a dandelion field and count every single dandelion. So the practicality isn't there for certain scenarios. Indirect observation. So it's sometimes easier to do this type of method if organisms are mobile. So if organisms are, fleeing the nest, or they are hibernating, or they are nocturnal, then it might be a good method to use if we can't actually find the organism themselves. And it also gives us some information about the organism's behavior. So maybe we're not just finding the population size, but maybe we're finding some of their habits as far as tracking them goes. Some negatives to indirect observation. It's just an estimate, okay? Direct observation is the only one that is not an estimate, but indirect observation is an estimate. It's difficult to do in large areas because you would be surveying a large area looking for tracks or looking for signs of life. That's difficult to do and time consuming. And it can be hard to interpret without understanding the organism's habits. So if I don't understand how many of a certain species of birds nest together, then I'm not going to have a good feel on how many birds are in each nest if I'm just counting bird nests. All right, moving on to sampling. So sampling is where I take that smaller area, count the number of organisms in the small area, and then I multiply it over the larger area. So this is good for making an estimate over a large area, and it can be a relatively reasonable estimate because you are counting the actual organism, you're seeing it, you're just counting it in a smaller area and you're making a judgment for the larger area. It's still an estimate, and a negative would be that you have to have a random sample. So sometimes you might see surveyors or ecologists use a square like that they've taped together, and then they throw it out into the field and you try and take a random sample that way because you don't want to place your sampling area where there's a high concentration of the organism that doesn't necessarily represent the entire field or the entire area that you're trying to survey. Mark and recapture. So we can gather information about the organism's health as well. So we get that additional data, which is a huge pro. We can study organisms' habits over time and monitor their health from year to year or from capture to capture. Some negatives of this method would be that it's still an estimate. The calculations are more involved, they're a little more complicated, and it's time consuming to be able to mark those organisms, catch them, send them back, then try and recapture them. It's a very time consuming method. Okay, so we have a couple of Pear Deck questions coming through. Which of the following is not a method of determining population size? And I did not turn on the Pear Deck link when I went through this, so I'm going to say that I think it might be the second option, but I forget what I put for the choices. Sorry, guys. So I will put a Pear Deck link version of this PowerPoint in as well. But just to recap, the four methods of population, determining population size would be direct observation, indirect observation, sampling, and mark and recapture. So whichever one is not one of those. Which method would you use to study a small area with an immobile population? Okay, so we have a small area, the organism's not moving. So if you put direct observation, then you would be correct, because if I am only counting a few of something and it's in a smaller area, then I can certainly do direct observation. Which method would you want to also study the health of an organism? So for this, to study the health of an organism, the best method give you some time to make your choice if you're doing the Pear Deck version. The best method would be mark and recapture. You actually get to physically observe the same organism throughout time. Which method would you use in a large area? So this is a little bit vague question, but I would say that you could use sampling in a large area. You could also use indirect observation, but sampling would be the best. Which method is the most accurate? So there are three methods that are estimates, and then there's one method that is not an estimate. So direct observation would be the most accurate. That's the method that is not an estimate. Which method would you use if you could not easily see or find the organism? So if I have an elusive organism, then I'm going to use indirect observation. I'm going to look for signs that the organism was there. So place a red dot over the method that is not an estimate. So you would place your red dot over direct observation. That's the only method that's not an estimate. Which method would you use to determine the number of birds living in this habitat? So if I'm looking at the birds' nests, what method am I using? I would be using indirect observation. And which method would you use to determine the number of people on a beach? Here, if I am monitoring this beach, I could probably just use direct observation because there's not too many people out and it's not a very large area. Alright, that is it for methods of studying population size. Please reach out to your teacher if you have any questions and complete the worksheet for today on population dynamics.